Headlines love the term super-Earth. Every few months, NASA discovers a new planet in the habitable zone. Kepler-452b, Proxima Centauri BTOI 700d. They call them Earth's cousins. Artists draw them with blue oceans, green forests, and fluffy white clouds. We look at them and see a new home, a backup plan for humanity. But this optimism is based on a lie. The reality of these worlds is not a paradise. It is a biological and physical nightmare. The term super-Earth only refers to mass, not habitability. If we actually traveled to these planets, we wouldn't find a second Eden. We would find a gravity trap that crushes our bones, a sun that shoots death, and an ocean without a bottom. We are not looking at new homes. We are looking at prisons. Let's start with the most obvious problem, gravity. By definition, a super-Earth has more mass than our planet. Kepler-452b, for example, has a mass 5 times that of Earth. Its gravity is estimated to be twice as strong as what you are feeling right now. To a generic sci-fi movie, this just means you feel heavy. Biologically, it is a death sentence. At 2G, your body weight doubles. If you weigh 80 kilograms, you suddenly weigh 160. Every step requires the effort of squatting with a heavy barbell on your shoulders. But the problem isn't your muscles. It's your blood. The human heart evolved to pump blood against Earth's specific gravity. On a super-Earth, your heart has to work twice as hard to push blood up to your brain. You would suffer from chronic dizziness, vision loss, and eventually, cardiac arrest. Fluid would pool in your legs. Falling down from a standing position would shatter your bones with the impact force of a car crash. And if life evolved there, it wouldn't look like us. To survive this crushing force, native creatures would be low to the ground, with thick, trunk-like legs and powerful hearts. Standing upright is a luxury only low-gravity creatures like us can't afford. But gravity is manageable compared to what comes from the sky. Most super-Earths we have found, including Proxima b, orbit red dwarf stars. These stars are smaller than our sun, so the planets must orbit dangerously close to stay warm. Being this close puts the planet in the firing line of a stellar tantrum. Unlike our stable sun, red dwarfs are violent. They frequently erupt with superflares thousands of times more powerful than anything recorded in human history. Imagine a world where, every few weeks, the sky turns blindingly white. A blast of X-rays and ultraviolet radiation slams into the planet, stripping away the ozone layer and sterilizing the surface. If you stood on the surface during a flare, your DNA would unravel in seconds. Even if life managed to survive underwater or underground, the atmosphere itself might not survive. The solar wind from these stars is so intense that it can physically blow the planet's air into space, leaving behind a barren, radiated rock. It is not a garden. It is a microwave oven with the door open. This proximity to the star creates another horror, tidal locking. Just like our moon always shows the same face to Earth, these planets are locked to their star by gravity. One side is an eternal day, the other an eternal night. There is no sunrise, no sunset. The star just hangs there, a giant red eye in the sky, burning the surface forever. The day side is a scorching desert where water boils away. The night side is a frozen wasteland of ice. The only place life could theoretically exist is the Terminator line, a thin strip of twilight between the burning day and the freezing night. But even there, the physics are chaotic. The clash between hot air from the day side and cold air from the night side would drive supersonic winds. Permanent hurricanes the size of continents would scour the surface without pause. It is not a home. It is a storm shelter. Now, let's look at the planets that kept their atmosphere, the ones covered in deep blue oceans. These are the Haitian worlds. They look beautiful, but they hide a dark secret in the deep. On Earth, our oceans are deep, but they have a bottom made of rock and sand. On a water-rich super-Earth, the oceans could be hundreds of kilometers deep. At those depths, the pressure is so extreme that water stops behaving like water. It turns into exotic forms of ice, like Ice 7. This isn't cold ice, it is hot, solid water, compressed by the weight of the ocean above. This layer of exotic ice acts as a barrier. It seals off the planet's rocky core from the ocean. This is catastrophic for life. It blocks the carbon cycle. It prevents nutrients from the core from reaching the water. But the trap goes deeper. Imagine an intelligent species evolves in these endless oceans. They are smart. They are social. but they can never advance. You cannot build a fire underwater. Without fire, you cannot smelt metal. Without metal, you cannot build computers, radios, or spaceships. They would be a civilization of philosophers and poets, trapped in the Stone Age forever, unaware that the universe exists above the waves. Finally, we reach the ultimate trap. Let's assume a civilization survived the gravity, the radiation, and the oceans. Let's assume they built a technological society on dry land. They are still prisoners. This is the gravity prison hypothesis. Space travel is governed by the Tsiolkovsky Rocket Equation. To leave a planet, you need to reach escape velocity. On Earth, we need to reach 11 kilometers per second. It requires massive rockets that are mostly fuel. On a super-Earth like Kepler-452b, the escape velocity is nearly 3 times higher. The fuel required increases exponentially, not linearly. To launch a single ton into orbit from a super-Earth, you would need a rocket the size of the Empire State Building. It becomes chemically impossible. The weight of the fuel makes the rocket too heavy to lift the fuel. Nuclear propulsion might work, but chemical rockets, the technology that got us to the moon, would fail. Any intelligent species born on a super-Earth is trapped. They can look at the stars, they can dream of them, but they can never reach them. They are prisoners of their own planet's mass. We search the universe for Earth 2.0 because we are afraid of being alone. But the data suggests that Earth is not just rare, it is a miracle. A perfect balance of gravity, rotation, atmosphere, and a calm star. So, when you see the next headline about a super-Earth, remember, size matters. And in the cosmos, bigger doesn't mean better, it usually means deadlier. This is the silent observer. Gravity is destiny.a.